friends, this is Mike Bell. I'm a biologist with the National Park Service. While I'm usually in the office crunching data, today I'm going to take you on one of my favorite trails near my house to talk about some of the local wildflowers. Let's go. Most days in the office, I'm trying to figure out how air pollution from human sources blows out to national parks and negatively impacts plants and animals. On top of trying to protect the plants, we're also trying to protect our clear views in national parks, so that when you go and you take a picture of one of the big overlooks, you get the most likes on Instagram that you can. I started my career with the National Park Service as a botanist at Craters of the Moon National Monument in Joshua Tree National Park. When I was there, I learned all about botanical diversity and just the scavenger hunt of searching for new and exciting species that grew and provided habitat for all of the animals in the park. Today we're at North Table Mountain in Golden, Colorado. These are ancestral lands of the Ute and Cheyenne tribes and are full of secrets that are written in the plants. Let's go take a look. All right, first stop is the hairy golden aster. This is scientific name Heterotheca villosa. You look at this and you might think, oh, this is a small sunflower, and you would be right. What is interesting about this plant and sunflowers in general is the flowers themselves. Most people look at this and think, oh, this is a sunflower. But when you look closely, you'll notice that there's actually a significant number of flowers connected at the base here. So we have two different types. The first are ray flowers. These are the ones that have the long petals on them. And then in the middle, there are disc flowers. And you can see when you look closely that the disc flowers are blooming on the outside and not yet blooming on the inside. And so if you think of either a dandelion or a sunflower itself, the dandelion has that, like the parachutes that come out, and the sunflower has the seeds that you're eating if you're playing baseball or something. And so each of these individual flowers ends up creating one of those seeds. The second piece that's really interesting about this plant is the hairy part of hairy golden aster. So when you look closely, you'll see these really small hairs on the plant surface. So these function in two different ways to help the plant survive. One, it prevents things from eating it. Because if you're coming in and if you're a small insect trying to get a bite, it's a lot harder to get your teeth in to that plant if you have to go through the hairs. The second is wind. Just like the hair on your head keeps you warm in the wintertime because the wind doesn't blow directly on your scalp, this slows wind down and prevents water from being sucked out of the leaf stems. Let's keep going and see what else we can find. Oh, this is perfect. This is the perfect companion to our last one. All right, so this is the prairie coneflower. And you're thinking, oh, that looks pretty similar to the last one. I see some ray flowers, I see some disc flowers, but why is that thing protruding up out of the middle? So, just like the last one, this is another sunflower species. Except this time, the head of the flower, where the disc flowers connect, is protruding out and not just in the middle. So just like before, you can see where these individual flowers, how they would all be packed together in the last example, but now are pushing up. Generally, these flowers bloom from the bottom to the top. And so if you look closely, you'll see still a couple flowers in bloom right at the top there. So as the seeds go, those seeds will form from the bottom to the top as well. Pretty neat, huh? Ooh, check it out, I found another one. And you can see in this one where not all of the flowers on here are bloomed yet. We're still moving up as they're developing, as they're blooming. So it's a really neat thing is that not all of these plants are going to produce flowers at the same time. By like naturally spreading out their flowering, they allow individuals to be pollinated at different times. This way, if there's a drought, there's like the plants that come up early are able to produce seeds, but then if there's late rains, they're able to take advantage of those pollinators still being around and produce seeds late into the season, help spread them in the future, create more wildflowers in our natural spaces. Cool. Speaking of the timing of plant development, we have some great examples here showing different phenology of different species. So look at this. The first one we have is this Lepidium species right here, and that's in brown. It's brown because it's already dead. This species is one of the first ones to come up in the springtime. Like as soon as it rains, this will come up. And that way, there's no competition for it. It's just that it's the earliest species, can bloom, seed, move on before anything else happens. The next, we have our friend, the golden aster, which is producing a ton of flowers right now because it needs to compete with all the other flowers that are up. Lastly, we have this white species right here. And you'll notice there's not even any flowers on it yet. How are you supposed to attract the pollinators with no flowers? So the interesting thing about this plant is that it doesn't flower until late in the season. And one of the things that it's adapted to be able to do that is these whitish leaves. And so looking at the leaves, if you think about when you wear a dark colored t-shirt, it gets really warm under the sun. But if you have a white t-shirt on, it reflects more of the sun and keeps you cool. The same thing's going on with this plant. And so instead of the leaves being dark green like everything around that's kind of nearing the end of their season, this plant can survive in the summer by reflecting more light so it doesn't get as hot, and can survive and still produce flowers once the rains have stopped come summer. Ooh, check this out. Got this little pollinator right here, some kind of beetle. You always think about the bees and the butterflies, but so many different bugs will land on these flowers, spread the pollen around, and help them out. So just because this guy's looking a little scary doesn't mean he's not good for nature. All right, I promise you this is the last sunflower we're going to talk about, but I wanted to point this out because we're going to talk about leaves. And so for this first example, we're looking at this and it just looks like basically a normal leaf. It's what we call a simple leaf. It's just one leaf attached to the stem. The other really cool thing about this sunflower, since it's on these like kind of long, has the long stems from which the flowers are attached, it allows it to rotate a little bit more than the other plants. And so these flowers will track the sun. So if you look, most of these are pointed right up at the sun. And as it moves across the day, the flowers will turn, keeping themselves, oh no, in line with the direction of the sun for the entire day. All right, continuing on this conversation about leaves, we now look at this little milk vetch species. So this one was blooming a long time ago. All the flowers are gone. But look at this. This is one leaf right here. You're like, wait, there's 1, 2, 3, 4, 5, 6, 7, 8, like 20 leaves there. Actually, this is called a compound leaf. And so a compound leaf means that it's split up, like each leaf it has multiple leaflets. And so each of these is like used to be a round lobe, and over time just got smaller and smaller. And one of the things that's really valuable about this is when you have a big leaf like this in a windy area, each of these little leaflets allow it to kind of flutter a little bit and prevent it from ripping. Because if you spend all the energy to grow this leaf, the last thing you want to do is get a hole in it. Then you're just going to leak water all over the place. Nobody's happy. So some of them will break up their leaves into smaller parts to help preserve them long term. You lose one little leaflet, you can shut that off and you can keep on growing. All right, I know I told you we were done with sunflowers, but I just want to show you this one more leaf here. So this is our coneflower. Looking at the leaf, you might look from a distance and say, oh, this is another compound leaf. But when you look closer, you'll see each of these are actually connected. So if this keeps evolving the way that it did maybe 500, 1,000, 10,000 years from now, this will be a compound leaf. But for right now, it's just lobed. So this is like the evolutionary progression to that compound leaf. Is first it lobes. Again, these are a lot more sturdy in windy, dry environments and provide less surface area, less area for water loss. Ooh, check it out. This is a long-leaved paintbrush. And can you guess why they call it a paintbrush? Because look at it, it's a paintbrush. So one of the cool things about this flower is that a lot of the color you see actually aren't flowers. When you look closely, you'll see that each flower, so here's our flower here, has this modified leaf underneath it that helps protect it from getting damaged. This is called the calyx of the flower. And so a lot of times when these are nice and tight and bunched up, you're actually seeing just these modified leaves that are the same color as the flower, because that starts attracting the pollinators to it early on. These are already going to fruit, as you can see as this is extending out here. But generally speaking, like an insect can land on the calyx and dip its nose into the nectar early in the season to get what it needs and to pollinate the flower. All right, I got to do it. I'm sorry, but looking at the coneflower again, because look at this, it's a different color. This one's all red. This one's yellow. This one's red. So one of the cool things about flowers is just like you and your brother, you may not have the same color hair. Your hair might be blonde, their hair might be brown. Just like this is the blonde version and the redheaded version of the prairie coneflower. This is called phenotypic variation. So they're the same flower, they just show up a little bit different in the world. And it's good. Hold up, check out this. This right here is a thistle poppy. So the reason they call it a thistle poppy is check out these leaves. Ow, ooh, ooh, ooh. They're nice and sharp. Just like those thistles, like the weeds that grow in your yard. You gotta like wear gloves if you're able to pull this out. But you wouldn't want to pull this out. Look, it's a beautiful flower. So the difference between this one and the ones we were looking at earlier is that this actually is a single flower. And you might look in here and say, what are all those? Like that looks like a bunch of little things. Those are all the stigma. So that's where the pollen comes from. That's what the bees are going to come and collect on their body and then carry to the next flowers. Then in the middle, this is the stigma, and that leads to the seeds in the plant. So when this pollinator comes in, touches the pollen, flies to the next one, pollen gets here, and then all of a sudden you have seeds growing in the fruit that will eventually come out of it. So lots of stigmas, lots of pollen, one big flower, thistle poppy. Found some lupins. Let's check them out. Oh man, these are mostly going to fruit already. Oh, so look at this. This is so cool. I forgot about this. All right, so here we have lupin seed pod. Nice and full. You can see like the beans inside. So this plant's related to a bean. This one, look at how it's twisted. It just shot the beans out. So what happens is this is called, when the fruit is dehiscing, it's opening up to let the seeds out. This one actually twists to try to make the seeds go a little bit farther. Because when you're a bean, you're not going to fly with the wind, and you're not going to get caught on anyone's fur. It's got to find unique ways to get farther away from the plant so you can spread out and find more places to grow. The other cool thing about this flower is look at these leaves. Oh, here's some good ones. So, like before when we saw that compound leaf, it was in a line like a normal leaf. This one is called palmately compound because, oh, it's backwards, but look, it's like a palm. They're all, the leaves are coming out from the middle. And if you look, they all kind of cinch off in that same way. So this is very common for the lupin species. So you'll see they'll have a different number of leaves, there'll be a different length and thickness, but all of them are going to have this palmate compound structure. All right, so these are a little bit dried out, but got a little bit of a lupin flower here. One of the cool things about this one versus the other ones is that these have a structure, the flower, that's called bilateral symmetry. So just like my face, this flower, you can split right down the middle and it's going to look the same on both sides. When these are nice and wet, this right here is like your little landing pad for your pollinator. And then it sticks its tongue up in there, gets the nectar in the back, finds some pollen, and can fly off to the next one. Woo-wee! Check out this guy. This one is beautiful. All right, so this is the wild bergamot. And this is part of the mint family. One of the ways I know that is if you look at this stem, it's square. You can feel it's flat on this side and it's flat on that side. The other way is that the leaves are coming off are opposite. So they're on opposite sides every time instead of alternating up the stem. The last way is if you rub this real nice and soft, it smells kind of like sage. So this is also related to the sage plant and just has a nice smell to it, to me. But if you're an insect, if you look at these leaves, you'll see very little damage. There's no holes. Insects aren't going to want to eat that. They're going to look at these leaves and they're going to try to bite into it. They're like, ugh, what was that? That's not what a leaf's supposed to taste like. So the chemicals that leaves create to prevent insects are actually something that people have learned to love. And we now spice our food with them. So whether it's oregano or basil or rosemary, all of those flavors were meant to deter insects from eating them. And now they make our food taste great. Plants are so cool. Ooh, look at this. This guy, we're almost at the end of the trail and found this wild rose. And so different than the ones you get in the grocery store because these only have 5 petals. The ones in the grocery store have been modified so you have like multiple layers of petals on top of petals and it just bumps up real tight. But if you look here, you can see when it's closed up before it opens, look just like nature's bouquet. And then, man, if you could smell this right now, so good. And so look again, we have more compound leaves, little leaflets, opposite side. Whoa! There it is. Check it out. This is the final flower on our tour. This is the Gunnison's Mariposa Lily. For those of you in Colorado, you're thinking Gunnison, like the city? Yup, one and the same. But this isn't just found between here and Gunnison, it's actually found across most of the West. This flower is named for John Gunnison, who's one of the early surveyors in the area. So he made a lot of maps that were taken back east, and thus a lot of little things are named after him. So this is in the lily family. This is, like we were talking earlier about the lupin flower having that bilateral symmetry. This one has radial symmetry. So if you notice, there's basically 3 exactly similar sections to this flower. Each of those leaves, if you follow it, each of the petals, if you follow it in, has the same structure. Well, thanks for joining me today. That's all I got for you, all the flowers I could find. Hope you learned something. Hope you had some fun exploring my backyard with me. This is my favorite thing, just to get on the ground, put your nose in the flower, and like see what's there. So have a great day. I'm gonna get back to the office, start making some maps, and helping our parks thrive. See you soon.